Hi there, in this video clip today I want to look at the manufacture of ammonia, NH3. This is made industrially by a process known as the Haber Process, Haber. How is it made? Well, this is how it's roughly made in this diagram. There's nitrogen gas and hydrogen gas. They're mixed and then they're passed into a reaction chamber. I'll talk about the conditions later on, and the ammonia comes out and is placed into a cooling chamber, and from the cooling chamber it's run off, so that would be the NH3 comes off because it's been condensed, and any unreacted nitrogen and hydrogen is then fed back into the reaction chamber. The conditions used to make ammonia are as follows, and I'll talk you through them a bit later in this video clip. They are elevated temperature, it's about 450 degrees centigrade, 200 atmospheres pressure, and a iron catalyst finely divided. That's how they make it. The nitrogen comes from the fractional distillation of liquid air, comes from liquid air, is distilled to give you the nitrogen, and the hydrogen is from North Sea gas. So that is roughly how it is made. The ammonia is used in two main industries to make fertilizers, I'll be looking at it soon, and to make explosives. Let's look at the conditions. This is the Haber process reaction. N2 plus 3 H2 gives you 2 NH3. That sign is reversible, and unless you get the conditions right, it would never react. The reactants would not give you those products, or you'd only get a small amount of product. Let's look at them step by step. Pressure, first of all, 1 volume, 3 volumes, so you're going from 4 volumes to 2 volumes. Therefore, the Haber process is favoured by high pressure. But high pressure comes at a cost. The higher the pressure, the more sophisticated equipment, etc. It's more expensive. So what we do is we compromise on the pressure. Increasing that pressure comes at a cost. Let's look at temperature next. There's the Haber process again, and gives you the 2 NH3. Now, the enthalpy change on this delta H is negative, and negative indicates an exothermic reaction, but we want it really to be an endothermic reaction, because endothermic reactions are favoured by a increase in temperature. But if you increase the temperature, it moves the opposite way. So what we do is we compromise on the conditions of the temperature and the pressure. and we speed up the rate of reaction by using a catalyst. Catalysts, I mentioned before, they are chemicals, ingredients that speed up the rate of a chemical reaction, but at the end of it they remain unchanged. So there are the three conditions, and if I plotted a chart, this is going to be the percentage yield, and this is going to be the pressure in atmospheres. You get a chart a bit like this, and as the temperature increases and the pressure increases, what we do is we have a compromise the pressure, and we compromise the temperature to give us the best or most effective, cost for the production of ammonia. Ammonia is used to make fertilizers and explosives, and we also get from simply converting the ammonia into nitric acid. Anyway, let's get on to the manufacture of fertilizers. You sometimes look on the side of a fertilizer bag and you see NPK, nitrogen, phosphorus, potassium, and you see things like 10, 10, 10, or maybe you get 20, 0, 10. These are the proportions of nitrogen to phosphorus to potassium. That one there with the 20, 0 to 10 doesn't contain any potassium. Why do we use fertilizers? Basically, they help plants, vegetation to grow. NPK, the nitrogen promotes growth in the leaves. The phosphorus promotes fruit production and berries, etc. Let's call it fruit, that could be a vegetable as well. And the potassium is for the overall health of a plant. That's what an NPK balanced fertilizer does. It contains a certain proportion of nitrogen, phosphorus and potassium to produce healthy plants, healthy vegetables, healthy flowers, etc. Where do we get the constituents from for the manufacture of NPK fertilizers? The answer is the ammonia is reacted with sulfuric acid to produce ammonium sulfate, and it can be reacted with other things as well. And if we took rock that comes out of the ground, massive big rocks of it, this is phosphate rock, PHOSPHAT, and would you believe it contains phosphorus? You can't use that rock directly. It has to be crunched up and made into something else before it can be used. And I'm not going into great detail, but the phosphate rock naturally occurs in the ground, is treated with nitric acid, and from that we get phosphoric acid, H3PO4. the phosphoric acid reacts with ammonia, and it forms ammonium phosphate, which is formula of NH4 3 times PO4. I'll balance it up now. So, phosphoric acid reacts with ammonia to produce ammonium phosphate, and also the nitric acid reacts with any calcium salts that you've got, and it forms other nitrates as well. And that is basically how fertilizers are made using ammonia.